everybody, and welcome back to the video for task 3.1, which is the first task of our Module 3 unit. In today's video, we're going to be talking about identifying the domain and range and intervals of increasing, decreasing, and constant from a graph, as well as interpreting the meaning in the context of a problem. Now let's break down this learning target. We're going to be identifying intervals of increasing, decreasing, and constant from a graph. And then at the very end, we're going to talk a little bit about interpreting the meaning of those intervals in the context of a problem. Before we can start identifying these intervals, we need to learn about something called interval notation. When we talk in math about intervals, we are talking about sections of a graph. So when we identify these sections, we're going to use a starting value and a stopping value. And then we're going to use symbols that are either brackets or parentheses. Brackets look like kind of squared off. And we're going to use brackets when there is a closed circle on the graph. We're going to use parentheses, which are rounded, and we're going to use these when there's an open circle on the graph, which literally looks like a not filled in circle, or when there's an infinity, which means there's going to be an arrow on the graph pointing that the graph goes on forever. Now for today's problems, we're going to be focused on increasing, decreasing, and constant. So let's do a couple examples where we just practice identifying intervals on the graph before we go into classifying those intervals as increasing, decreasing, or constant. For each of these graphs, I'm going to ask you to identify the interval that you see on the graph. In this first picture, if we look at the kind of highlighted section of the graph there, the beginning of this section of the graph, if you were going to draw like a wall where it starts, would be when x is -2. And the ending section of the graph, if you were going to draw like a wall where it ends, would be at the +3. So for our interval notation, we would put -2 first because that's the left number, and then +3 second because that's the right number. So we get the numbers by looking at where the interval begins and ends, and we always put the left number on the left and the right number on the right. Then we need to use symbols. Because this point right here has a closed circle, we would put a bracket here. And because this point over here also has a closed circle, we would use another bracket by the 3. And the reason for that, again, is because we use brackets for closed circles. Now, let's look at a problem where we don't have all closed circles. So you'll notice that this next graph is very similar to the first graph, except for this time, when I look at this section of the graph, the end point here has an open circle. So let's see how that changes our notation. The first thing is, if I was going to draw a wall where this section of the graph starts, it would be when x is -2. And if I was going to draw a wall where this section of the graph ends, it would be where x is +3. So I would put the -2 at the beginning because that's the left starting point. And then I would put the +3 at the end because that's the right side, the stopping point. Now, since this end has a closed circle, I would put a bracket here because closed circles means we use brackets. And since this side has an open circle, I would use a parentheses here because whenever we have an open circle, we need to use parentheses. So this big difference here is that when this is a closed circle, we use a bracket, but as soon as this becomes an open circle, it's a parentheses. Now let's look at a couple examples where there are some arrows. So one of the things I want to remind you is that this x-axis is a little bit like a number line. If we keep going to the right, eventually we're going to reach positive infinity. And if we keep going to the left, eventually we'll reach negative infinity. For this graph, because there's an arrow on the graph, it's going to keep going to the right forever. So that means eventually you would head towards positive infinity. That means that I can put a wall on the left side of this graph, which means it starts at -2, but I can't really put a wall on the right side. It's going to keep going. So my end number here would be positive infinity. If I were to write my interval notation, I would have -2 as the beginning, and I would have positive infinity as the end. Now the left side has a closed circle, which means there's a bracket because there's a closed circle. And the right side is going to have an open circle because there's an infinity. I'm sorry, not an open circle. It's going to have a parentheses because there's an infinity, because there's an arrow. So as the big difference here is that when you've got this arrow, you need to use a parentheses because that's going to be headed towards infinity. For the last example here, we've got kind of the same idea, only this time the arrow is on the left side. What that means is I can put a wall on the right side saying that this graph is going to stop at the +3, but this arrow means it's going to keep going to the left, which means eventually this graph is going to meet the negative infinity. When I write my interval, negative infinity would be the beginning, and the +3 would be the end. I would use a parentheses, I'm sorry about that, a parentheses on the left side because there's an infinity, or in other words, there's an arrow on the graph. And I would use a parentheses again on the right side because there's an open circle here. Okay, now that we kind of get the idea of you have a left number, you have a right number, and then you use parentheses or brackets depending on what kind of circles or arrows you have, let's talk about these different types of sections we're going to be identifying. We're going to be identifying today sections of the graph that are increasing, decreasing, and constant. In math, the word increasing means that it's a section of the graph that is going uphill as we move from left to right. So you're going to be looking for a section of the graph that is going uphill. Keep in mind, you always drive on your graph starting from the left side and moving to the right. Decreasing is going to be a section of the graph that is going downhill as you move from left to right. So this is going to be a section of the graph that is going downhill. And again, keep in mind, you always drive on your graph from left to right. So this is going to be downhill. And constant is going to be a section of the graph that is flat as you move from left to right. So that's going to be something that looks like this. It's flat. And again, you drive starting from the left. What we're going to do right now is look at this graph and see if we can identify the sections that are going uphill, downhill, or are flat. If I'm looking for the uphill section of this graph, it's going to be the section that starts from -3 and ends at 0. So this section would start from -3 and it would end, sorry, not at 0, at +1. If I wanted to list that in interval notation, I would write -3, 1, because the left number is -3 and the right number is +1. Since the left side here has an open circle, I would use a parentheses. And since the right side here has a closed circle, I would use a bracket. If I want to now find the sections of the graph that are decreasing, or in other words, going downhill, I would be looking at this section of the graph right here. Now, what you'll notice is that this section of the graph starts from the 4, but then there's an arrow. And because there's an arrow, it means it keeps going. So I would be not stopping, I would be going towards positive infinity. If I were to list this in interval notation, I would say from positive 4 to infinity, because the 4 is the left number and the infinity is the right number. And then I would use a bracket at the 4 because that's a closed circle, and a parentheses on the infinity because infinities always have parentheses. Last but not least, if I'm looking for a section of the graph that is constant, then I'm going to be looking at this kind of middle section of the graph right here. This section is constant because it's flat. It's not going uphill, it's not going downhill. This section of the graph would start from the positive 1, and it would end at the positive 4. Which means my numbers are going to be 1, 4, and then I would use a bracket on the 1 because it's a closed circle, and a bracket on the 4 because it's a closed circle. All right, let's do a couple more example problems to kind of make sure we understand this idea of increasing, decreasing, and constant. So let's do one at a time. Let's start with increasing. I'm going to highlight the sections of the graph that are increasing in green. Now again, increasing means uphill. So I'm going to be looking at this section of the graph, this section of the graph, and then this little section of the graph. That means that I'm going to have 3 separate intervals as part of my answer. The first interval has an arrow here. So that means that the graph is going to keep going forever. That means that on the left side here, I'm going to be approaching negative infinity. And on the right side of this section, I'm going to be approaching the negative 6. So my first interval here would be negative infinity, comma negative 6. Since infinities are always going to have parentheses, I'm going to put a parentheses here. And since this negative 6 has a closed circle, I'm going to put a bracket here. The next green section that I highlighted would start from negative 2, and it would end at the positive 1. So I would write negative 2, comma 1. The first end has an open circle, so I would put a parentheses, and the second end has a closed, and I can tell it is closed because it's just connected there. It's not open, so I would put a bracket. Last but not least, this little mini section here starts from the 3 and it ends at the 4, which means I would have 3, comma 4. Again, I can tell that these are closed because it's nice and connected. There's no open circles, so I would put a bracket and another bracket because it's closed. Now let's talk about decreasing. So decreasing is going to be sections of the graph that are going downhill. So I'm going to be looking at 2 separate sections here and here. We're going downhill. And again, I'm highlighting those in pink. If I wanted to list those sections, the first one would start from the 1 and end at the 3. So I would say 1, comma 3. Since everything is nice and connected here, there's no open circles, I'm going to use brackets for both. The next section would start from the 4 and end at the 8. So I would have 4, comma 8. The 4 is going to be closed because it's nice and connected there. The 8 is going to be open because there's an open circle. So I'm going to use a parentheses. And those are my 2 decreasing sections. And last but not least, I'm going to be looking for a section of the graph or more than one section of the graph that is constant, which is going to be this kind of flat section right here. So I'm going to highlight this one in orange. I'm going to say for my constant section that it starts from the -6 and it ends at the -2. Since the -6 has a closed circle, I would use a bracket, and since the -2 has an open circle, I would use a parentheses. Okay. Now, one of the other tasks we're going to have in this unit is to interpret the meaning of a value in a context of the problem. So throughout this module, you're going to be asked to interpret values in the context of a story. In other words, tell me what those numbers mean for this story. Here are some strategies you're going to use to help you answer these questions. Number 1, label the axes on the graph if they are not labeled for you. So you're going to want to label the x-axis and the y-axis. Then you're going to want to state the meaning of the x values using units. So make sure you say like it's grams, it's miles, it's, hours, it's seconds. And you're going to want to state the meaning of the y values using units. So again, say it's the distance in miles or it's the amount of water in gallons. Here's an example. Josh leaves home and goes on a drive. The x-axis represents time in minutes and the y-axis represents distance in miles. Identify if each feature is true or false, and if it is true, interpret the value in the context of the question. Step number 1 here is going to be to label. So it tells me in these instructions that the x-axis represents the time in minutes. On the bottom here along the x-axis, I'm going to label that this is the time in minutes. And the y-axis represents the distance in miles. So along the y-axis here, I'm going to write distance in miles. For each of these statements, step number 1 is tell me if it's true or false. So statement number 1 says f of x has one interval on which it is decreasing. So let's look at the graph. I'm going to start by finding the decreasing intervals. Decreasing in this context means going downhill. So let's see. The only downhill interval I see here is this one. Since there's one interval on which it is decreasing, I would say that this is true. Now I need to say what that means. So what does it mean decreasing here? Well, this interval means that there is one interval. So again, I'm just using the words from the original. F of x has one interval on which it is decreasing. Well, what are we measuring here? We're measuring the distance. So there is one interval on which the distance is decreasing. So in this story, if there's one interval on which it is decreasing, that means that there's one interval on which the distance is decreasing. For the second problem here, it says the graph is constant over the interval from 4 to 7. So let's figure out where the graph is constant. I'm seeing the graph is constant from 4 to 7. So I agree with that. From 4 to 7, the graph is constant. Now in this case, the graph is measuring the distance. So we would say the distance is constant from 4 to 7 minutes. Because the values here, the 4 and the 7, are measuring the minutes in this problem. For the next example, it says the graph is increasing over the interval from 7 to 9. So let's see, from 7 to 9 would be from here to here. The graph is increasing. So, because in this case the graph is measuring the distance, we would say the distance is increasing from 7 to 9 minutes, because in this problem, the 7 and the 9 are x values, which are the minutes. Last but not least, the graph is increasing over the interval from 9 to 13. Well, let's see here. From 9 to 13, the graph is actually constant. It's not increasing there. If you look between the 9 and the 13. So this is actually false, because the graph is not increasing. It's actually constant. Last but not least, this problem says, for problem number 3 here, identify the intervals where the graph is increasing. Interpret the differences between those intervals in the context of the problem. So there's 2 parts to this question. First, tell me where the graph is increasing. So if we go back to our graph, we've got one of our increasing intervals right here, and we've got another one right here. So the first thing that I would do in my answer is I would list those intervals. So I would say that this graph is increasing from, the first interval is from 0 to 4, and I'm using closed brackets for both because there's no open circles. And the second interval would start from 7 and go to 9. And again, I'm using brackets because they're both closed. The second part of this question, though, is to interpret the differences between those intervals in the context of the problem. What I'm noticing is that although both sections of this graph are going uphill, this section is steeper. What that means is that the speed or the distance is increasing faster from 7 to 9 than it is from 0 to 4, because this is a steeper section. So we would say the distance is increasing faster on the interval from 7 to 9 than it is on the interval from 0 to 4. So it's increasing faster because this part of the graph is steeper. It has a higher slope. All right, that is it for today. Thank you guys so much for watching, and have a wonderful afternoon. I'll see you soon for some practice.